Today in preview lesson 3 we're talking about exponents. And the first thing that we want to deal with is integer exponents. And we want to remember that when we deal with exponents, when we talk about exponents, exponents represent repeated multiplication. So when we think of 5 to the third power, that means 5 times 5 times 5. The base tells you the number that's multiplied over and over again, and the exponent tells you how many times it's multiplied. So we can see that in general, any number to the nth power is just going to mean a times a times a times a times a until you have n of them multiplied together. So there are n factors of a, that many. So for example, now we have 2/3 to the third power. By definition, what that means is 2/3 times 2/3 times 2/3. And remember from the last lesson, when we multiply fractions, we simply multiply straight across on the top and straight across on the bottom. So 2 times 2 times 2 is 8. Then on the bottom, 3 times 3 times 3 is 27. So we find out that 2/3 cubed is 8 over 27. Then for example B, -3 to the fourth power. Again, by definition, -3 times -3 4 times. And we remember that when we have 4 negatives multiplied together, the answer will be positive. And then 3 times 3 times 3 times 3 gives us an answer of 81. Now, part C, example C here is one that people mix up a lot of times. You have -3 squared. The negative is not included in that exponent. So what this really means is negative 3 times 3. And so negative, we can think of it with parentheses around it, but -3 times 3 is going to equal -9. So we have to remember just what the definition of exponents are. It means you're multiplying something by itself multiple times. Now, some other exponents. If a is not equal to 0, so the base can't be 0, and it's any other real number, and n is any positive integer, then a to the 0 power equals 1. So in other words, just about anything raised to the 0 power is 1. The only thing that doesn't work is 0, 0 to the 0 power. And a to the negative nth power is just equal to that reciprocal, 1 over a to the n. So for example here, in part A, 5/8 to the 0 power, well, anything to the 0 power is 1. There's not even any work to do. That's just a definition. For part B, x to the -4th power, by definition, that's 1 over x to the 4th. Again, there's not really any work to do there. It's just a matter of using that definition to rewrite it. Now for part C, we have -3 raised to the -3rd power. Again, the definition here, (1 over -3 cubed). And then we have to remember what -3 cubed is. You're multiplying -3 3 times. And when we do that, -3 times -3 times -3 is -27. Now we want to write that as -1/27. But that's our answer for part C. So again, the definition's there. Anything to the 0 power or anything to a negative power. Some rules of exponents or laws of exponents. The first one we have is that when we have two numbers with exponents that have the same base, we simply add the exponents. A really easy way of showing this is if we use an example. So let's say, for example, we have 2 to the 3rd power times 2 to the 4th power. Now remember what that means. 2 to the 3rd power is 3 2's multiplied together. 2 to the 4th power is 4 2's multiplied together. And when we write it out that way, it's very easy to see that there are 7 2's multiplied together, and that's going to be 2 to the 7th power. If we are dividing two numbers that have exponents, it's the same type of rule, only this time we subtract. So again, let's look at an example. We take 3 to the 5th power divided by 3 squared. Again, by definition, what that means you've got 5 3's on the top, 2 3's on the bottom, and if you think about canceling, you can see what we have left is 3 cubed, which is those exponents, 5 minus 2. So that's just a shorter way of doing that so that we don't have to write out using the definition every time. Any power raised to another power, you multiply those exponents together. Again, an example here. By definition, that means you're going to multiply 2 cubed by itself twice. And using our rule from number 1, we add those exponents and we get 2 to the 6th, which is also the exponent 6 is just 3 times 2. If we look at taking the exponent of a product, that exponent just applies to each of the factors inside. So if we think about an example here of 3x to the 3rd power, that means 3x multiplied 3 times. So and if we multiply that together, I'll leave it in exponent form. We can see we have 3 3's multiplied together and 3 x's multiplied together. So that exponent goes to each one of those factors inside the parentheses. And then finally, the same thing happens with fractions. If you've got a fraction raised to a power, the exponent just goes with each of those fractions. If we think about 2/3, let's make it variables. Let's just say we have x over y, and that's raised to the 3rd power. Again, that means xy times itself 3 times, or x over y, sorry. And we can very clearly see that's x times x times x on the top, and it's y times y times y on the bottom. And again, we see that that exponent is just applied to each of those parts. And so that's how we get these these properties. It's really just from the definitions of what exponents are. So now, looking at this one, we've got x to the 5th times x cubed. That's using property number 1. And that rule says when we're multiplying numbers with exponents, we simply add the exponents. So this will be x to the 8th power. For part B, First, we have to rewrite it using the definition. Actually, we don't even need to. We've got y to the 8th times y to the negative 15th. We still simply add those exponents. 8 plus negative 15 is negative 7. And so then to write that in standard form, a negative exponent means that we write it as a fraction, 1 over that y to the 7th power. For part C, we actually do have a division, c to the 11th over c to the 4th. And remember, that means we subtract them. That's using the second property. And 11 minus 4 is 7. So we get c to the 7th power. Now, things start getting a little bit more complicated when we have more than just one thing. So in this case, look at what we have. The first term is just 3. Times a to the 4th times b to the 5th. And we really don't have to do anything with that. But the second one, that second factor, we've got an exponent. So remember our rule that says when you have powers of a power, that power, in this case of 4, applies to each thing inside of that parentheses. So we're going to have 2 to the 4th power a cubed raised to the 4th power and b to the 4th power. So now we have to start simplifying things. I'm not going to do anything with this first one yet, but now 2 to the 4th power is 2 multiplied by itself 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. And then a cubed to the 4th power. Remember, we multiply those exponents together. Power of a power. That gives us a to the 12th. Okay, and these things are just all multiplied together. So we multiply the numbers together. 3 times 16 is 48. A to the 4th times a to the 12th. We add the exponents. Get a to the 16th. And finally, b to the 5th times b to the 4th. You add the exponents again, b to the 9th power. There's nothing else we can do to simplify that because we've got each factor just one time. For part B, again, we've got a fraction. That negative 3 goes with each thing inside the parentheses. So once we've rewritten it, we can start simplifying. This is a little bit tricky, but the one thing you want to realize is when you have a negative exponent, remember we rewrite it as 1 over that value. 1 over a value is algebraically how we write reciprocals. So what happens with those negative exponents, actually we'll deal with that in a second. Let's go ahead and just simplify first. We use multiplication, so 2 times negative 3 is negative 6. And 3 times negative 3 is negative 9. Now what I was talking about with those negative exponents is they just go, when we talk about reciprocals, it just moves it from the top to the bottom, or it would move it from the bottom up to the top. So what this changes into is z to the negative 9th moves up to the top and becomes z to the 9th. You have 4 cubed on the bottom, and y to the 6th. Now the last thing that we need to do is deal with that 4 cubed. 4 times 4 times 4 is 64. So our answer here is z to the 9th over 64y to the 6th power. Some more laws of exponents. I think we've got two more. First of all, and this is one we could have just used, if you've got a fraction raised to a negative power, all that does is take the reciprocal of the fraction, and that then it would be b over a to the nth power. So that's one we could have just used on that last problem, that last example. And then finally, this is another thing that we just did. If you've got a negative exponent on the top or on the bottom, a to the negative n will move down to the bottom and become a to the m. b to the negative nth power will move up to the top and become b to the positive nth power. So notice that property is when you have a negative exponent, it will just move either from the top to the bottom or from the bottom to the top. So some more examples of this. Once we have those properties, the first thing I typically deal with is the negatives and take care of those. So now this b to the negative fifth will move down and become b to the positive fifth. A to the negative third will move up and become a to the positive third. And then we still have the b squared on the bottom. So now we just simplify what's there. We add the exponents. We get 4a to the fifth on the top. On the bottom, we get 2b to the seventh. Again, we're just adding those exponents. And then you always want to look and see if you can simplify. And in this case, the 4 and the 2 can reduce. They're both divisible by 2. And we end up with 2a to the fifth over b to the seventh power. For part B, probably take care of those negatives first again. And we'll just rewrite the first one for now. But remember what happens when you have a fraction. This thing, we take the reciprocal. So now it's z squared over 4y, that whole quantity squared. Now we move that exponent in to each of those factors. And as you get more used to this, some of these steps you'll be able to skip as you start seeing the patterns, but I want to show all the steps for right now. This gives us 8y cubed, 2 times 2 times 2 is 8, over z cubed, times z squared squared. You multiply those exponents, you get z to the 4. 4 squared is 16, and y squared. Now remember with fractions, when you're multiplying them, we multiply straight across. So we're going to get that, but then again, we want to do any canceling that we can. 8 and 16 cancel the 2 and 1. Y cubed and y squared. Remember, we subtract those. So the y squared cancels with y cubed, and you have just y to the first on the top. The same thing happens with z cubed and z to the fourth. So we end up with yz over 2 for our answer. Another thing we need to talk about with exponents is scientific notation. And you want to think about scientific notation We use this a lot in science because you're dealing with really big or really small numbers, and that's how we want to think about it, really big or really small numbers. So when a number is expressed in the form a times 10 to the nth power, where this a value is between 1 and 10, the way we think about it is there's only one digit in front of the decimal point or to the left of the decimal point, and n is an integer. This is scientific notation. So what we want to do is, first of all, rewrite a number in scientific notation. And the way I think about it is, if the number is large, the exponent on that 10 will always be positive. If the number is small, the exponent on the 10 will always be negative. So if we're looking at A, 34,500 is a large number. The first thing we know is that the decimal point is going to get moved here in front of here behind the 3. So we're going to have 3.45. Always times 10. And again, since this is a large number, we know our exponent is positive. But the question is, how far do we move the exponent? The exponent starts off, that didn't work out the way it was supposed to. That was not supposed to be an 11. The decimal point starts off behind this, the 0, behind the number. So it's really right here. So what we want to do then is see how far it moves. And we can see that the decimal point moves 4 spaces, so this means it's going to be 3.45 times 10 to the positive 4th power. Okay, so again, the key thing, decimal point has to go behind the first non-zero digit, and then we count how far it moves. In example B, again, the decimal point goes behind the first non-zero digit. So we will have 1.23 times 10. The difference this time is this is a very small number, so it's going to be a negative exponent. But we still just count how far the decimal point moves. And it's going to move 1, 2, 3, 4, 5, 6 spaces. So this becomes 1.23 times 10 to the negative 6th power. So the decimal point behind the first non-zero digit, and then you count how many spaces the decimal point gets moved. Just to emphasize that, and you can't see it anymore, but since it's a large number, we move the decimal point to the left 4 spaces, and in the other one, since it's a small number, the decimal point gets moved to the right 6 spaces. In example 7, we're going to rewrite it in standard form. So again, 6.52 times 10 to the negative 3rd means that that is a very small number. So we start out with the 6.52, and we have to move the decimal point 3 spaces, and we need this number to be small. So our decimal point will be right there. Now we can't just leave those spaces blank, we have to fill them in with zeros. So our answer is 0.00652 when we write that out in standard form. For part B, we see that that exponent is positive, and we're going to move the decimal point 5 spaces. So we start out with 2.3, and we move the decimal point 5 spaces. And again, we fill in with zeros. And we see that our answer is 230,000. So scientific notation, if you just keep in mind, big numbers have positive exponents on the 10, small numbers have negative exponents on the 10. It's pretty easy to work with. And again, this comes up just to reinforce that idea. Small numbers move the decimal point to the left 3 spaces to make it a small number. Large numbers move the decimal point to the right 6 spaces to make that a large number. Your assignment for this section The previous section number 3 is on page 29, and you can see the numbers written there. That's also on your assignment sheet that I gave you before, but please start working on these. You'll have time tomorrow in class to ask questions on any that you're not getting, but go ahead and get started on those.